Hello everyone, we're here to present our dissection of ReactOS, an open source operating system that aims to be fully compatible with Microsoft Windows.
I'm Charles.
And Daphne.
And I am Jeff. Let's explore how ReactOS works, its algorithm, threads, handling, and what makes it strong and weak compared to other OSs. What is ReactOS? ReactOS is a free open source operating system that's designed to be binary compatible with Windows application and drivers. That means it can run many Windows programs without using any Microsoft code. Everything is built from scratch by a community of developers. Its goal is to give users a Windows-like environment that's completely open, lightweight, and transparent. How ReactOS works. ReactOS is modeled after Windows NT architecture, which means it has two main layers, user mode and kernel mode. In user mode, you'll find application system libraries like kernel32.dll and user32.dll and the Win32 subsystems. These communicate with kernel mode where the heart of the system runs. These include the kernel, device drivers, memory manager, and process scheduler. Together, this layer allows ReactOS to behave just like Windows, but all in open source form.
Process scheduling in ReactOS. Process scheduling in ReactOS is based on preemptive, priority-driven, multi-level feedback algorithm, just like Windows NT. This means that every thread is given priority level and the system always runs the thread with the highest priority first. If two threads have same priority, ReactOS uses round-robin scheduling, letting them take turns using the CPU. To make sure no threads gets ignored forever, the OS can temporarily boost priority of waiting threads to avoid starvation.
Threads in ReactOS. In ReactOS, a thread is the smallest unit of execution. It's like a mini program running inside a process. Each thread has its own stack, CPU context, and control block called thread, but all threads inside the process share the same memory space. Threads can be in different states: ready, running, waiting, or terminated depending on what they're doing. The operating system manages threads through the scheduler, which decides which one should run next based on their priorities. Example: when you open multiple tabs in browser, each tab might have its own thread running in parallel. Kernel and thread interaction. The ReactOS kernel is responsible for handling a low-level interactions between threads, memory, and hardware. It uses a component called the dispatcher, which coordinates the movement of threads between states. For example, from waiting to running. Threads can synchronize with each other using mutexes, semaphores, and events, ensuring that shared resources are accessed safely. This makes ReactOS efficient and prevents data conflicts when multiple threads run simultaneously.
Strong points of ReactOS. ReactOS has several strong points that makes it unique. First, its Windows compatibility or compatible, meaning you can run Windows apps and drivers without needing Windows itself. Second, it's open source, which makes it great for students, researchers, and developers who want to study how an operating system works. Third, it's lightweight. It can run on very old or low spec computers. And lastly, it's community driven with full transparency in its development.
Weak points of ReactOS. Despite its potential, ReactOS still has some weak points. It's still in the alpha stage, meaning it's not stable enough for daily use.
Some Windows programs and drivers don't run properly yet because compatibility isn't 100%.
Development is also slow since it relies mostly on volunteers.
And compared to modern systems, React OS still lacks advanced features like strong security, 64-bit support, and full network team stability.
Thank you for watching our React OS dissection presented by Jeff.
Charles,
Not me.
Special thanks to the React OS open source community for keeping this project alive. You can learn more at reactos.org. Bye!
bye bye!